Hi there, it's playtime again, and today I'm playing with two portable oscilloscopes. One is the CREATEC SC01. Let me remove that cover. It's that baby, and that one comes from the year 1987. And on the other hand, we have the oscilloscope from Tooltop. The model is ET120MC2, and this means plus one additional oscilloscope set or probe. That makes it the Pro version. The Pro version comes with two probes, the normal version with one probe. And I would recommend you to buy the Pro version with two probes, because we will see in a moment. Let's first unpack this. So we have two oscilloscope probes. They don't look too bad. We have an USB-C charger cable, because this one has a built-in battery. There is an additional cable with two crocodile clips and that special coaxial connector. They also have this connector, and that's the reason why I recommend to take two probes, because this oscilloscope doesn't have BNC. It has this small coax connectors. They are quite good, but well, they are not standard BNC, so maybe a little bit difficult to find probes for that. Okay, let's compare the sizes. The new one is much smaller than the old one. It's almost the same thickness. Well, it's a little bit thicker here. This one has mechanical switches for both channels. It has two channels and a trigger input, or is it a trigger output? Well, I don't know. I think it's an input. Here we have a mechanical on-off switch, which I personally like, because, well, it makes things easy and you know exactly when it's on or when it's off. It has a color display, it has a backlit display. This one has a monochrome LCD with no backlights, making it a little bit difficult sometimes to read. But it has here this red or orange button here, this screw. That's the contrast. There is a potentiometer for the contrast. And you have more buttons. Yeah. Therefore, the use is a little bit more complicated, because you almost all the time need the manual to see what buttons you have to press for which functions. It's not very intuitive. This, on the other hand, is very intuitive. It has a menu button. If you scroll down, there are even more menus. And in fact, the first menu item I changed was this beeper here, because per default it's on. And where's the go out button? Okay, here. And it's pretty annoying if you want to set some stuff here. So let's turn that beep off again. Off. Okay. Menu. That's it. Much better. Of course, the oscilloscope, well, no. The oscilloscope does also come with the user manual, and it is, as far as I have seen it, not too bad. It's in English. It's in understandable English. That's not always the case. And they have a couple of examples here. Yeah, that's okay. This one has a stand and it has a built-in battery which can be charged here. That's the USB-C charge port. This one doesn't have a battery. It needs this large power brick that has a connector like this with output voltages of 5 volt, 12 volt and minus 12. And it is connected down here like that. So if you want to, this is the cover. If you put the cover on the back side, you can adjust it here in a certain angle as much as you want. And it also has a stand, an adjustable one. But the problem is this one still has a stand that is in one piece. It already has some cracks here. And we had many of them, so there was a time when each technician had one of these. None of them actually use them very much because it is not very useful because of the display, for example. But many of these stands here, or covers, however you call it, are cracked and broken and yeah, got lost. So there is it. That's the display. That's how it looks. An old LCD display without background illumination and a pretty low resolution. Now we can do some tricks. For example, we can interpolate all these dots, and that works like, let me see. Display multi to equal. Yes, much better. We can also fill the areas. Display multi 1 equal. Yep. It even looks better on camera than in real life. Oh no, okay. It's a question of the viewing angle. Display multi 1 CCA. That kills that command. Okay, I'll show you how you actually do it. So for example, if you want to change your time base, you say channel 1 multi, no. Okay, channel 1 norm 10 microseconds. And maybe you saw how this changed. Let me turn the interpolation on. That is display multi 2 equal. Okay, we can see it a little bit better now. We have 10 microseconds. Let's go back to 5. 1 norm 5 microseconds. Bim. And it does it. The voltage is simple. You only have to move this mechanical switch here. I wish they had a mechanical switch for the time base, but that was not possible as it looks like. Okay, let's compare that to the new one. Well, connecting to the oscilloscope is a little bit trickier because we don't have a BNC, but we can use that crocodile clip that goes to this banana adapter here, and that goes to, guess what, BNC. So, not beautiful, but working. Well, it's even beautiful. Okay, so power on. Ooh, we have a lot of stuff. So, how does it work? Well, the easiest way is to push the auto button here, and it does everything automatically. I have read the manual, but I don't know. Oh, okay, that's the time base. We are in this mode. When there is a plus symbol, it means expand in any direction. So it expands the time here. Yes, pretty nice. And this one, yes, that's the voltage. Where is the setting? We have 1 volt per division. Now we have 500 millivolts, 2 volts per division. It's 4 volts peak to peak. My amplitude here on the generator says 2 volts peak to peak. Or is this the total voltage? Maybe my generator is off. Maybe this one displays a wrong setting. You know what? Let's go back to here. So the problem is here we don't have a grid, but I can turn that grid on. Display multi 3. So we have a dot. Display multi 4. So we have a crosshatch here, and it says it is 1, 2, 3, 4 volts per division. My generator says 2 volts peak peak. Okay, the image is pretty good. Interestingly, I see a blue frame here around. I don't see that in person. Oh yes. Okay, the display, did I say it's pretty good? No, it's not pretty good. It's pretty awful. I mean, okay, in this direction it's good, but this direction here, I mean, that's not too much, and it's completely away, and I can't really see the blue. Okay, maybe not the best display, but it's also not the most expensive oscilloscope. And by the way, this display is, well, if it had a larger resolution, it would be not too bad, but yeah, and everything is slow and okay. Another feature of this oscilloscope, something that this oscilloscope doesn't have, this one has a generator. Well, not a sound generator, a wave generator. We can go to menu, generate out, and we have we can have a square wave, a triangle or a sine wave. And where was, oh, here. That's, you can select the kilohertzers. It's from 10 Hertz to 100 kilohertz. Okay. Let's take 10 kilohertz. Okay, we have that. And here we can set the voltage, 3 volt peak to peak. Okay, let's go to 2 volt peak peak. And yeah, let's measure the output of that multimeter. So I set the generator here to 10 kilohertz, 2 volt peak peak. And let's see what we have here. And of course I also have an auto button here. It just turns on all the channels, which I don't need now. Okay, let's see. It looks like we have also a positive signal. Let's see how. Let's connect that to ground. Center this. DC coupling. Yes, we are completely above the zero line, so we only have positive waveform. This is not AC, this is wobbly DC. If I go to AC coupling, yes, that's okay. So I think they didn't install a coupling capacitor here, so they go from some sort of chip directly out, and so that's the way, or that's the reason why we have DC here and not AC. Let me see if I change the square wave. Yes, it also goes from 0 to 2.5. That's 2.5 volts. We should have 2 volt peak peak. Let's go back to the, that is also more than 2 volts. The sine wave, yes, it's 2 point, I don't know, 2.2, 2.4 volts peak peak. Okay. And also the waveform is very, like, it looks like a stair. It's, I don't know how many bits resolution that is, but it looks like it's only, I don't know, 8-bit or something. So you clearly see this stair, steps there. Let me see, here it's okay, that's only on or off. Yeah, here we have steps, a lot of steps. Let's go for a higher voltage. What's the maximum? 3 volt peak peak. Okay, we have 1, 2, 3.5. The steps are not less, no, it's the same amount, but they are bigger. Let me turn that down, 0.5 volt peak to peak. Okay, we are a little bit below the trigger. Ooh, that's... Where is my trigger? Trigger. Here. Yes. Okay, so that is interesting. Doesn't really look. By the way, that's something that annoys me on my Rigel oscilloscope. Why do they put a glossy screen here? I mean, you can see anything, everything, what I'm doing. Thankfully I'm not naked, but for example, if the sun is shining outside, I can't use the oscilloscope because I see my windows in the mirror here. Yeah, it is as it is. Maybe all these guys all are sitting in a dark room. No, that way it's even worse. Okay, everything has its downsides. Okay, so the measurement of the mini oscilloscope is, well, it does, so it's about something about what it's coming in. It's actually displayed, so the question is, how good is the generator? And if I go to, for example, 100 kilohertz, that's the highest setting here. I said 50 before because I missed this 100 here on the side. And the Rigel says it's 104 kilohertz, so we are 4 kilohertz off. That is 4%, and well, that's not the best one. Because, I mean, frequency generation, that is something that there is I think there is a quartz crystal inside, and you have to divide that somehow, and 4% off, okay. So let's see how it does on 1 kilohertz. So we can also jump sideways, that's good. 1 kilohertz is 1.009, 1.01. Okay, that's about 1% off. It's better, but not the best. Let's see if we take let's go to 100 hertz. How much do we measure here? We measure 100.5 hertz, that is 0.5%. So the lower the frequency, the more accurate it is. Okay, maybe we should only use it up to 20 kilohertz, and for example for audio amplifiers. So let's see, 20 kilohertz, how good is that? It says 20.4. 10% is 22, 1%, that's about 2%. Okay, so it seems it's pretty linear. It is most accurate at the low frequency, and the higher you get, the more you're off. But for, let's say, for most tests and for everything you can measure with that, it's okay. You can output the sound into an amplifier. You can measure if the sound comes out or where it stops and what components are probably faulty. Okay, so yes, that's 37 years ago. That's today, and I would say I still like this one better because it has the clear display, it's easier to read, it's way faster in updating its stuff. For example, if you press the menu button, you get there in an instant. And well, this can do a lot more. It also can do some mathematical functions. You can multiply both channel, divide, add, subtract, and all this stuff. And you can also multiply with a stored waveform, or show a difference to a stored waveform. That stuff this one can do, but it's not intended to do so. I remember I tried to use one of these when it was relatively new. It was fancy. It is, as I said, complicated because you have to memorize a lot of numbers and sequences of these buttons. And Well, the display is, it just has not enough pixels. That's the problem. If it was a higher resolution or even a little bit bigger display, that thing would be pretty nice. I don't know what the price was. I think it was pretty expensive, something around, well, I make that up, but I think it was around 2,000 Swiss francs then, while this one is about 50 bucks now. And yeah, that's how time changes. Okay, I hope you enjoyed that little video. Thanks for watching.